Silly me. I have to give you the rest of the data, don't I? So the soil went like this. Get ready. Get a pencil. Get ready to put this into your data table. This is the order from 0, starting temperature, 21, 21, 22, 22, 23, 24, 24, 25, 26, 27, 27, 28, 28, 28, 29. I hope I didn't make any mistakes. I'll send this to you as a little, I'll scan this and send it to you as well. Then the next for water, it would be 21, 21, 21, 21 all the way down to 4 minutes. So everything's 21 through 4 minutes. Then 1, 2, 3, 4, 5 22s, and the last measurement was 23. That's your water heating. Then your water cooling is simple. It's all 23 except the last at 7 minutes was 22. And it goes like this for the soil. It was first 29, then 4 28s. 1, 2, 3, 4 28s, 2 27s, 1, 2, 3 26s, and 4 25s. Again, 29 for your first. There is no starting temperature for that. It's just a continuation. So 29, then 320, 1, 2, 3, 4 28s, 2 27s, 3 26s, and 4 25s. So the graph should be pretty straightforward. You should be able to go to Google Sheets and plug in your data from the table. You're going to make a line graph of in one column for soil, heating, then cooling. Do them together, not a separate heating and a separate cooling, one line for both. So you just put in the times. You need 7 minutes in your first column every 30 seconds. So 0, 30, 1, 130, 2, 230, 3, and so on. And then your first column could be soil, your third column could be water. And in those columns, for soil and water, every measurement, first heating, then cooling, no break, no units in the cells. You put the units in a row at the top, label your columns, time, soil degrees centigrade, water degrees centigrade, and then select everything you've put in and insert a chart. Should be very straightforward. And then add that to the Google Doc, which will then be the answers to on page 4 for your conclusion and guiding questions. So you didn't do page 4. And again, the instructions there are to hand in the completed research hypothesis, density calculations found on page 1, completed data tables from page 2, calculations completed in the boxes on page 3, graph completed in using Google Sheets and attached to this document or attached to the final conclusion and answers. That is its own doc. I would put in fact, I would put the graph and the answers together. All right, I think that's all I need to tell you for now. And that specific heat, I've already ended this once, but it's all right. Let's just take a look what the temperature of the water is. It's gotten down to just about 21. And what did I do with the soil? I don't know what I did. Oh, it's under here. Oh, I dumped it, right? Oh, who knows? Okay, bye. 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 So I said that we would determine the volume of our soil. So we'll use this measuring cup and get a rough sense of that just by pouring one. The other will lose. I'm losing a little at the edges. You can scrape that, and then you might even see it floating around in the air like the other day when I showed you that when we were drawing this. This has got a lot of clay in it. So volume here looks to me to be well, it's less than 200 milliliters. Exactly how much less, I don't have a good enough beaker really to say, or measuring cup. So I would say we call it, it's definitely, at one point it's at 150. Let's call it 170. So let's call the volume of our soil 170 milliliters. So that will enable you to determine the density of the soil, since you know the mass. So the mass was 200 and the volume is 170 milliliters. 170 milliliters. So that was a long video. Hope it wasn't too painful. You should have been able to get most of the information that you need to complete the lab. There is a extra credit. The extra credit is a little exploration of the relationship between the specific heat of water and the specific heat of soil. One of them, water, is 4.18 joules per gram for every degree of centigrade temperature change, and the specific heat of soil is 0.79 joules per gram of every degree of centigrade temperature change. And that relationship, if you simply take 0.79 and divide it into 4.18, gives you an amount of heat necessary to warm up water. How much more heat? It's a number about 5 times as much. And we want to see if that actually is borne out in the data. So for the extra credit, you're going to investigate whether or not the actual amount of heat matches the difference in specific heat capacity, whether it's about a 5 times as great a need for heat to raise the temperature for water as that for soil. So that'll conclude the lab, and finish this up over the next week or so. There's going to post it today, Wednesday, April 8th, and we're going to go into a slowdown for the next 7 days, and I hope you enjoy that. But I will see you on some sort of remote access device next week. So enjoy.